Middle School Science, Potential and Kinetic Energy Lesson. Potential energy. This diver has just jumped up from the end of the diving board. After she dives down and is falling toward the water, she'll have kinetic energy, or the energy of moving matter. But even as she is momentarily stopped high above the water, she has energy. Do you know why? Stored energy. The diver has energy because of her position high above the pool. The type of energy she has is called potential energy. Potential energy is energy that is stored in a person or object. Often, the person or object has potential energy because of its position or shape. So what is it about the diver's position that gives her potential energy? Because the diver is high above the water, she has potential to fall towards Earth because of gravity. This gives her potential energy. Gravitational potential energy. The potential energy due to the position of an object above Earth's surface is called gravitational potential energy. Like the diver on the diving board, anything that is raised up above Earth's surface has the potential to fall because of gravity. You can see other examples of people with gravitational potential energy in this figure. Both the sled and the gymnast have gravitational potential energy. Gravitational potential energy depends on an object's weight and its height above the ground, and can be calculated with this equation. GPE is equal to weight times height. Consider the little girl on the sled, pictured here. She weighs 140 newtons. And the top of the hill is 4 meters higher than the bottom of the hill. As she sits at the top of the hill, the child's gravitational potential energy would be 140 newtons multiplied by 4 meters, and that would equal 560 newton meters. Notice that the answer is given in newton meters, which is the SI unit for energy. A newton meter is the energy needed to move a weight of 1 newton over a distance of 1 meter. A newton meter is also called a joule. Question. The gymnast on the balance beam pictured here weighs 360 newtons. If the balance beam is 1.2 meters above the ground, what is the gymnast's gravitational potential energy? Well, her gravitational potential energy will be, we use our formula for gravitational potential energy, GPE is equal to weight times height, and we plug in 360 newtons times 1.2 meters, and we find that that equals 432 newton meters, or 432 joules. Elastic potential energy. Potential energy due to an object's shape is called elastic potential energy. This energy results when an elastic object is stretched or compressed. The farther the object is stretched or compressed, the greater its potential energy is. A point will be reached when the object can't be stretched or compressed anymore. Then it will forcefully return to its original shape. Look at the pogo stick in this figure. Its spring has elastic potential energy when it's pressed down by the boy's weight. When it can't be compressed anymore, it will spring back to its original shape. The energy it releases will push the pogo stick and the boy off the ground. Question. The girl in this figure is giving the elastic band of her slingshot potential energy by stretching it. She's holding a small stone against the stretched band. What will happen when she releases the band? Many of you have done this, so you know that the elastic band will spring back to its original shape. When that happens, watch out. Some of the band's elastic potential energy will be transferred to the stone, which will go flying through the air. Other forms of potential energy. All of the examples of potential energy described above involve movement or the potential to move. The form of energy that involves movement is called mechanical energy. Other forms of energy also involve potential energy can include chemical energy or nuclear energy. Chemical energy is stored in the bonds between atoms of compounds. For example, food and batteries both contain chemical energy. Nuclear energy is stored in the nuclei of atoms because of the strong forces that hold the nucleus together. Nuclei of radioactive elements, such as uranium, are unstable and so they break apart and release stored energy. Kinetic energy. What could these 4 photos possibly have in common? Can you guess what it is? Well, all of them show things that have kinetic energy. So let's define kinetic energy. Kinetic energy is the energy of moving matter. Anything that is moving has kinetic energy, from atoms and matter to stars in outer space. Things with kinetic energy can do work. For example, the spinning saw blade in this photo is doing work of cutting a piece of metal. Calculating kinetic energy. The amount of kinetic energy in a moving object depends directly on its mass and velocity. An object with greater mass or greater velocity will have more kinetic energy. You can calculate kinetic energy of a moving object with this equation. Kinetic energy, or Ke, is equal to 1/2 the mass times the velocity squared. This equation shows that an increase in velocity increases the kinetic energy more than an increase in the mass. If the mass doubles, the kinetic energy doubles as well. But if the velocity doubles, the kinetic energy increases by a factor of 4, so it quadruples. That's because velocity is squared in this equation, or raised to the power of 2. Let's consider an example. In this figure, Juan is running on the beach with his dad. Juan has a mass of 40 kilograms and is running at a velocity of 1 meter per second. How much kinetic energy does he have? Substitute the 3 values for mass and velocity into the equation for kinetic energy. When you do, you get Ke is equal to 1/2 times 40 times 1 squared. Well, 1/2 of 40 is just 20, so now you have 20 times 1 squared. 1 squared is just 1, so 1 times 20 ends up being 20. So your answer for how much kinetic energy is 20 Newton meters, or 20 joules. Notice that the answer is given in joules. This is the unit for energy. Summary time. Kinetic energy is the energy of moving matter. Anything that moves has kinetic energy. The amount of kinetic energy in a moving object depends directly on its mass and velocity. It can be calculated with the equation Ke equals 1/2 mass times velocity squared. Potential energy is the energy that is stored in a person or object. Gravitational potential energy is due to the position of an object above Earth's surface. The object has the potential to fall due to gravity. Gravitational potential energy depends on an object's weight and height above the ground, and the formula is GPE equals weight times height. Elastic potential energy is due to an object's shape. It results when an elastic object is stretched or compressed. The more it is stretched or compressed, the greater the elastic potential energy is. Chemical and nuclear energy are other forms of potential energy.